For many years, the mountain stillness of Beardsley Flat in the high Sierras was broken only by the rhythmic chug of logging trains which crossed the Stanislaus River in this remote valley. R.E. Hartley, engineer for the Oakdale Irrigation District, packed into this area on horseback in 1924 and selected the 700-acre flat as a potential site for water storage. At this point, the canyon narrows to less than 800 feet, with rocky promontories on each side, a perfect spot for a dam. Early in June 1955, the contract for this project was let to the Tri-Dam Constructors, a group of 4 corporations who began almost immediately on clearing and building a roadway down the mountainside to Beardsley Flat. A Model D9, largest bulldozer made by Caterpillar, was used to help build the 4-mile road. Its 13-foot blade cut a wide swath in the mountainside. As soon as the road was passable, heavy equipment was brought in by truck. By early July, rock and other overburden was being removed prior to drilling a diversion tunnel around the dam site. A concrete batch plant was begun downstream from the construction area. Work was begun on clearing the trees and brush from the area where the earth-filled dam was to be built. After the removal of timber, shovels moved into the hillside, removing all loose material to make a clean surface on which to place the dam. To excavate the diversion tunnel, a battery of 8 drills was mounted on a truck. By the middle of summer, the tunnel was well underway, with drilling and rock removal going on 16 hours a day. Immediately downstream from the dam site, work began on the excavation for the power plant. An open cut was made from there to the downstream portal of the diversion tunnel. Scalers clung to the hillside, clearing the loose rock. The contractors' workshops were set up in the reservoir site from which most timber had now been cleared. Forms for the tunnel lining were erected at the carpenter shop, then dismantled and transported to the tunnel portal in sections. Material for the concrete was excavated from a pit alongside the river and carried to a screening plant just a few hundred yards away. Here it was stockpiled. A bulldozer pushed it onto the conveyor belt. It was carried to the screening and washing plant. From here, continuous belts carried the graded material to stockpile. Concrete was mixed in a plant just a short distance downstream from the dam site. It was carried by ready-mix truck to the tunnel. A coffer dam was built between the dam site and the diversion tunnel. This would later direct the flow of water out of the stream bed. It was leveled and compacted with heavy equipment. A drag line was used to excavate the power plant site. Irrigation district directors visited Beardsley frequently to observe progress. From the power plant site, we can see the cut-and-cover conduit section, which will carry water to the turbine. This section is heavily reinforced with steel and will later be backfilled. Early in March 1956, the power plant substructure was finished up to the generator floor, and the river was flowing temporarily through the diversion tunnel. The work of locating the anchor bolts for the precision machinery which will go into this building was an exacting task. With the riverbed dry at the dam site, work could now proceed on removal of the unsuitable material in the foundation area. Bedrock lay 40 feet below the river channel. By the middle of April 1956, the site had been cleaned and fully prepared for the construction of the dam. The sides were carefully washed. Final debris was hand-shoveled from irregularities in the foundation rock. Water was pumped out of the remaining holes. An eroded seam in the rock was carefully filled with concrete. The dam could now be built. All the various types of material required for construction of Beardsley Dam were found within a mile or two upstream of the site. As work commenced on placing the embankment, progress also was being made on erecting the steel framework at the power plant. As summer began moving into the Sierra in 1956, work commenced in the spillway area. Forms were erected for the counterfort wall, which will tie the spillway and dam together. Material was beginning to flow onto the dam, which showed a definite pattern when seen from above. Beardsley is 1,200 feet thick at stream bed and consists of alternate sections of rock fill, pervious sand and gravel, impervious core, pervious sand and gravel, and rock fill. The pervious sand and gravel material was dug from pits in the future lake area. At one point, a huge 4-yard shovel was used. 3 bucket loads filled a truck. The impervious core material was also excavated from the reservoir area and loaded into moving trucks which never stopped on their round trips to the dam. After the material was placed on the dam, bulldozers leveled it and pneumatic rollers compacted it. A steady parade of equipment marched back and forth over the embankment 16 hours a day. By midsummer, the power plant superstructure was rising. we can now see the first of the rock fills which will be placed on the upstream and downstream faces of the dam. The counterfort wall is beginning to show its form. Drilling has begun in the spillway area. This mountain of solid rock had to be cut to great depth to form an inclined chute between the spillway crest and the river downstream of the dam. One year after commencement of work, Beardsley was taking shape as a dam, and the power plant building was nearly complete. The trash racks were installed in the penstock tunnel intake. Nerve center for all this activity was the second floor of Sparrow's store building at Strawberry. Here were the offices of Tudor Goodenough engineers, headed by B.W. Goodenough, project engineer, and S.R. Overholser, assistant project engineer. Here, Mr. Goodenough is checking one of the plans with Mr. Overholser. An office force was kept busy with the many plans and computations necessary on a project of this size. Plans were carefully filed for easy access. A huge volume of typing was required. Many computations had to be made. In the same building, Tri-Dam surveyors had their offices. This was a joint venture of R.E. Hartley and John Duff. Mr. Hartley followed the dream of these dams from their earliest conception. His partner, Mr. Duff, supervised the construction surveys for the Tri-Dam project. In their offices, drawings were made and all changes noted as the work proceeded. By the 1st of August, 1956, Beardsley Dam had reached the halfway point in volume of material placed. As many as 175 pieces of equipment and 425 men were at work on the project simultaneously. Trucks were moving constantly over the roads between the borrow pits and the dam. As soon as the material was placed on the embankment, bulldozers leveled it, and water was added. Then came the huge 50-ton pneumatic rollers, which compacted it. Several times a day, control test samples were taken of the different types of material that went into the dam. This sample of the earth core will be tested for compaction, density, and material gradation. The size of the earth sample taken is measured by filling the hole with sand of known weight and volume. In the laboratory, the material is sifted to check the gradation and remove the larger pieces. A sample is then placed in a cylinder mold. Next, it is carefully compacted. Then it is leveled to ensure the proper amount. The cylinder is then weighed to check its density. A sample from this cylinder is placed in a tray and weighed while damp. When it is re-weighed dry, it will indicate the amount of moisture in the material. By fall of 1956, work had progressed in the spillway area and the pier structures were beginning to rise. Concrete for the spillway crest was mixed in the batch plant on the job and carried by ready-mix truck. At the spillway site, it was poured into a bucket and carried by crane to the forms. Massive steel reinforcing goes into this portion of the spillway crest. At this point, the concrete will be over 6 feet thick, covering the network of reinforcing steel which here supports the workmen. Down the spillway chute, shovels were busy removing the rock and earth. Material for the gates and hoisting mechanism was beginning to arrive at the spillway site. The upstream side of the dam is receiving its final rock face with material excavated from the spillway. This material was carried by truck, first downstream, then up and over the dam to be deposited on the upstream side. As fall approached, the crest of the dam was beginning to narrow, but still the various segments were visible. The spillway piers and crest were nearly finished, and installation begun on the first gate. Concrete was being placed in the chute sections, while giant cranes placed the steelwork for the spillway gates. This was a precision job requiring careful handling and adjustment, because the gate will have to make a perfect seal, yet ride its track freely. Mr. O.H. Tucker was the project manager for Tri-Dam Constructors on Beardsley Dam. As the Pickering Lumber Company Railroad, which crossed Beardsley Flat, would be inundated by water stored in the reservoir, it was necessary to build a new section of track across the dam. After the first fall rains, burning of the timber slash was begun in the reservoir area, and the railroad was beginning to take form. Installation work on the power plant machinery went forward, while the switchyard structures were being erected alongside. By December 1956, work on all 4 spillway gates had progressed. The bridge which will carry the railroad across the spillway was being put into place. Concrete guide walls were constructed along both sides of the spillway to carry water to the river below. Time out for lunch as crews pause in their work. Concrete for the spillway chute lining was pumped from the crest, and vibrators were used to consolidate the mix. Christmas of 1956, and all 4 spillway gates are in place. The dam has risen to its crest, 320 feet above bedrock. Early in 1957, when water began backing up in the reservoir area, equipment and supplies had to be removed to higher ground. Final adjustments were made on the spillway gates prior to painting and lowering them into position. With the railroad finished and the lake rising, Beardsley was rapidly approaching completion. Meanwhile, work went forward on the After Bay Dam a little over a mile downstream from Beardsley. This was to be a rock-filled, timber crib dam, 250 feet long. Its purpose will be to regulate the fluctuating discharge from Beardsley Power Plant into the river downstream. At maximum, it would contain 250 acre-feet of water. With Beardsley Dam finished and the lake half filled, testing began in the powerhouse. Here the water is bypassing the turbine. With the After Bay Dam completed, water began passing through its 6-foot diameter outlet. Water rose rapidly behind Beardsley Dam due to the rains which came in the mountains early in 1957. This reservoir was designed to hold 97,500 acre-feet of water. By June, the reservoir was filled to capacity and presented a beautiful sight in the vast mountain terrain where it lay. it was possible to test the spillway gates to check for any needed corrections. Dedication ceremonies for the upper works of the Tri-Dam project were held at Beardsley Power Plant on the 15th of June, 1957. The Irrigation District Directors, engineers, and construction supervisors were present, along with many ranchers from the valley who would benefit by this great project. The ceremonies began with an introduction by John Vreeling, Chairman of the South San Joaquin Irrigation District Board of Directors. He was followed by Edwin Coster, Chairman of the Oakdale Irrigation District Board of Directors. He in turn introduced Ralph Tudor of Tudor Goodenough Engineers, Tri-Dam project engineers who surmounted many of the complicated problems. Mr. Tudor introduced N.R. Sutherland, President and General Manager of the Pacific Gas and Electric Company, who expressed friendly relations with the district and referred to the mutually beneficial contract which assured payment for the dams through the sale of power. The most surprised person on the platform was Russell Hartley, who was singled out for honoring at this occasion. After being called to the front of the platform, Mr. and Mrs. Hartley learned that the reservoir behind Beardsley Dam was to be hereafter known as Hartley Lake. Mr. Hartley reminisced over the years of work and dreams which this day saw fulfilled. Harvey O. Banks, Director of the State Division of Water Resources, who gave the dedication address, spoke to the assembled crowd on California's great water problem and the splendid way in which the people of the Oakdale and South San Joaquin irrigation districts were handling their own needs without the aid of state or federal funds. Now, with the completion of Beardsley Dam, the logging trains can cross the canyon once again, and the people of the valley below have another large reservoir of much-needed water on which to draw.